Hello and welcome to this month's video vlog. In this vlog, we're going to demonstrate an application of a milliamp device protecting a submersible water pump and a typical submersible water pump system installed the way we like to see it installed. So you'll notice in this application a right angle Filmac fitting. This fitting is the fitting on the inside or the warm side of the wall. The pipe going outside of the wall is the pipe that goes to the submersible pump in the lake. So the water's coming in through the fitting. It goes in through this braided nylon hose to give us some flexibility. We can ignore this fitting for now. It's actually for future irrigation purposes. It actually feeds up the hill for irrigation from the lake water. So we go up through the braided nylon hose and then into the pressure system and brass manifold through a Filmac male adapter compression fitting. This is a fairly standard manifold, but it's done with ultra high quality componentry. So everything's brass. The pressure switch is a square D pressure switch. We also put in a liquid filled pressure gauge. The liquid-filled pressure gauge is really nice, and the reason it is that the indicator on the gauge doesn't bounce around. It stays steady and consistent, so it's easy to read and it's very accurate, and it makes for a much nicer install. So we have bibs here to clean out sediment. We've got a high-pressure relief valve right here, and we've got a valve that turns the pressurized system to the building on and off. When it's in direction of the flow, it's on. When it's 90 degrees to flow, it's off. To demonstrate that gauge, I'm going to turn on this bib and I'm going to run some water through a hose and you'll see the pressure drop in that gauge. So this is a pressure gauge that's set to go on at around 40 psi, and it'll engage the pump, and then the pump will shut down at 60 psi. So we see it falling off now, and then you'll note that it will begin charging the system just around 40 or slightly below. And now the pump, which is a 1/2 horsepower, 12 gallon per minute pumps, now bringing the pressure back up to stasis, which will be around 60 psi or a little bit more. While we're watching that, something that's important to note is that we put a check valve in the line here. Pumps have a check valve. It's not really a check valve, it's called a flapper valve, and it's to prevent water from exiting back through the line and into the pump. This check valve in here actually works as a precautionary measure. It's like putting your thumb on the top of a straw. After the water charges in through the inlet, once it's reached pressure, which it has now, the check valve stops and it closes right there so that water cannot flow back through the pump. Okay, and in this part of the video, I want to explain the electrical connections for a submersible pump through a pressure switch. So from the milliamp device, the load conductor goes through and it goes up to the pressure switch. The pressure switch is a 2-pole switch. There are 2 contacts inside that pressure switch. In a 240 volt circuit, there's 2 lines, line 1 and line 2. And when we do a submersible pump, we break both line 1 and line 2. That means when this system has come to pressure and the pump shuts off, the electricity stops right there at that pressure switch. It does not continue through the lines and into the lake. When that pump is shut off, there is no electricity in the conductor that's feeding the pump in the lake. And that's very important. So through a 2-pole switch, we break both line 1 and line 2. When this system calls for water, it engages the starter, and the starter is a capacitor start, and it starts the pump, and it's that simple. And the pump is fed through this armored protected cable. Please be sure to stay up to date by reading our newsletters, our social media pages, and reviewing our website at www.heatline.com. And thank you for watching.